read chapter 6, you totally should. When I read with my Kindle, I highlight interesting ideas in text, and this one was full of them. The chapter explores the idea of temporal difference learning. This is an idea that was developed by Richard Sutton and is arguably the most powerful and interesting method in AI. I know that neural networks have gotten a lot of the attention in recent years, but I honestly think that reinforcement learning, TD learning as a type of RL, will prove to be more powerful and impactful in the long term. Chapter 6 discusses how temporal difference learning solves the credit assignment problem that Angela was just mentioning. Back in the 1950s, Marvin Minsky tried to use the idea of reinforcing good behaviors and punishing bad ones as a way to teach machines. This worked well for simple problems. He was studying mazes, but for more complicated ones, it didn't. The problem is obvious when you think of it. If you can only give feedback at the end of a long sequence of decisions or actions, how is the machine supposed to know which specific moves were good, which were bad, and which didn't matter? When I started kind of working in this area, it was certainly a question that I had. The cool thing is that when Rich Sutton and Andrew Bardo approached the problem 25 years later, Rich didn't just try and find an optimal solution. He wanted to figure out how animals actually do it. I love that kind of algorithm design, using nature to teach us and give us an advantage. Rich realized that what you need is something in the system giving feedback along the way. Instead of reinforcing behaviors using actual rewards, what if you reinforce behaviors using predicted rewards? You reward the AI when it thinks it's winning. His solution is what we would call an actor-critic method. The critic looks at the current state of the game board and makes a prediction about the final outcome. This essentially means assigning a value to the current board position. The actor decides which action to take and gets rewarded when the critic thinks the actor's move increased the likelihood of a winning result. This means the signal in which the actors learn is not rewards, but the temporal difference in the predicted reward from one moment in time to the next. That's where the name comes from. Now, don't get me wrong. This sounds like a totally circular approach, right? It turns out it actually works. There's a bootstrapping that happens between the two sides, the actor and the critic. Now, what was the most interesting and exciting part for me? It's actually the second part of the chapter. At some point, everyone here has heard of dopamine. If you're like me, you thought it had something to do with pleasure or rewards. Well, it turns out this isn't the whole story. The second part of the chapter walks you through some really interesting neuroscience experiments that show the way that dopamine concentrations vary in our brain is actually consistent with TD learning. It took a couple of years for researchers to see the connection, but once they did, a lot of puzzling neuroscience experiments suddenly made sense. I thought this was absolutely fascinating bit of science, and I'm embarrassed to say that I didn't know about it before. To be honest, I would not be surprised if at some point in the future the work discussed in chapter 6 produces a Nobel Prize. Maybe